We can find the power series of a given function using term-by-term differentiation or integration, algebraic processes, substitutions, and so on. And sometimes we can simply recognize that the function represents a geometric series. So here we have a constant of 1 and a ratio of x. And therefore we can write this function as a geometric series. So a is 1 multiplied by the ratio to the power of n. And we know that this series converges when the absolute value of the ratio is less than 1. And that gives the radius of convergence. And this tells us that the interval of convergence is from -1 to 1. The power series representation of sine x is given here, and we're asked to find the power series representation of cosine x. So remember that the derivative of sine x is cosine x. So we can either expand a few terms of this series and differentiate them one by one, or we can simply differentiate with respect to x. So we have -1 to the n, and then using the power rule for differentiation, we have 2n plus 1, and reduce the exponent by 1. And that's divided by 2n plus 1 factorial. So 2n plus 1 is going to cancel in the numerator and denominator, and we thereby obtain the following infinite series, which represents cosine x. And I encourage you to verify this by obtaining the Maclaurin series for cosine x. Let's find the power series representation of the following function. So we can say that it almost looks like a geometric series. So we can try some algebraic manipulation. So factoring out 3. And then we can write x squared on 3 in the numerator. So this looks like a geometric series where the constant is x squared on 3 and the ratio is x on 3. So therefore we can write the function as an infinite sum of the constant multiplied by the ratio to the power of n. And you can simplify this further by adding the exponents. So there'll be x to the power of n plus 2 over 3 to the n plus 1. And note that the geometric series converges when the absolute value of the ratio is less than 1. So therefore we obtain the absolute value of x is less than 3, and therefore the geometric series converges over the interval from -3 to 3.